Riemann, all main function of Riemann sphere is just a rational function of Z, or rational of W scale. So you may think that this would be a Riemann sphere, and this is a complex, one-dimensional complex torus. And this is actually true because you have a following mapping. So you have eta, okay? So identify according to lattice. And so I just like to point here something like Riemann class Z. Then Z has a mean. So it doesn't, this is independent of the choice of this representative. And this goes to C bar. Because for Z0 goes to infinity, but 1 over Kz becomes 0 at Z equals 0. It's a polar over 2, so. Okay. So in this way, you get a mapping. And you can show this is a sort of holomorphic mapping, and if you express this map in using a local coordinate, everything is given by a holomorphic function. You may wonder why. This is a monomorphic, so why you get a holomorphic mapping? Because at the point, at the pole, you have to choose this coordinate. This is W coordinate. And then this is holomorphic here. I'm sorry, maybe I'm talking too fast. And actually, this field extension corresponds to this mapping. So you can express that field extension by using the geometry of the Riemann one-dimensional complex manifold. So one-dimensional compact complex manifold is usually called Riemann closed Riemann surface because Riemann first studied very carefully. And actually, it's very interesting that you can imitate sort of the Galois theory here also. And then Galois group is replaced by the fundamental group of the Riemann surfaces. And they're just sort of the really parallel things. Okay, so this is one remark. And second remark is you have this relation again, like that, still. And then you consider geometry. I mean, what that geometry? So, day before yesterday, and also yesterday, I talked about it's another complicated form. Then what happens in our case? Yeah? So, and this is given by a very nice way, namely, this is given by minus kx, now minus ky, now plus 1 over 4 of k prime x minus k prime y, k x minus k y squared. So this is isosceles. But even if somebody knew that you are encoded some numbers, but you cannot many such things. But usually technique today they are using that if they choose a huge prime numbers, and then using this n. P and Q are secret. But using this n, you give some key to make the decoding, encoding key. You can open it, but you cannot decode because you don't know this P and Q. Of course, if you use maybe 2 or 3 years using a huge computer, maybe you can find out P and Q, but it's useless. So that in that way, they make a call. But this is a prime number. But using this elliptic, you can do a more sophisticated code also. So in that way, you can serial elliptic becomes very, very popular today. And the point is, on the elliptic curve, you can introduce a group structure. Even if this is defined over the finite field or any field, you can always introduce this group structure. And using this group structure, you can find many, many interesting things also. This is one thing I want to talk. And what's next? Okay. Yeah, and also this elliptic has a deep relationship with number theory. And probably you already know, I said that this is, I call Eisenstein series. And this has a very interesting properties. Namely, if you choose A, B, C, D is SL to Z, I mean also A, B, C, D, Z, and AD minus BC, so determinant is 1. Then, what you get? G2 of A tau plus T, C tau plus T becomes what? C tau plus T cos of T tau, and G3 So such a form in Coulomb function over the upper half plane is called a modular form. So it's a very interesting thing to study in number theory. And moreover, if you take the discriminant of this coefficient, so actually, if you start from the E and tau and construct this relations, you can already find that this is non-zero. That means that the cubic equation 4xq minus g2 x minus g3 has distinct roots, 3 different roots. And so g tau, this is also the very nice modular form. And this becomes c tau plus d of 12. And now, the most interesting function is j of tau q. And actually, it's better to add multiply some numbers, but basically it's okay. Now, this is called elliptic modular function because a tau plus b, c tau plus d is j tau. If A, B, C, D is to Z. Because of this. Is that G2 or G3? I thought it's G2. And this has also very interesting meaning, but maybe I took too many things. So probably today I'll stop here. And tomorrow I talk a little bit about the Jacobi and the average result of the adversary and inverse, Jacobi's inverse problem. And then I talk a little bit about non-Euclidean geometry. What is good? I can go further in this direction, but what do you like? Also, Feynman-Russell is also related to this problem. So it's really sort of the heart of the, even not modern mathematics. It started from this direction. And also it's related to algebraic geometry. I didn't talk anything. But anyway, I think that Jacobi's inverse problem is very important, so I'll talk a little bit about. And also that this upper half plane is deeply related to the non-Euclidean geometry. So maybe that would be a good continuation to the going to the subject problem. So maybe I will stop today. I'm sorry I talked too much.